so stall strips, various types of stall strips, other types. So what's the, everybody's done with their quiz, right? Okay, stall strips, what's the purpose of the, which side of the wing supposed to stall first? Dan, which end of the wing supposed to stall first? Where's the wing supposed to stall first? He just said it, if you were listening. What? Root, good, root of the wing. Okay, so, just as Beechcraft found out later that they had a problem. So their grand solution was, let's drill holes in the leading edge to ensure that we can put a stall strip on there so it doesn't stall violently. So they added these cute little brackets and then charged a lot of money for their mistake, right? Isn't that aviation? Oh no, we're going to have to come out with an AD. Unlike automotive world where they come out and they'll say, hey, we have a recall. Rarely does that ever work in aviation. You can't say it doesn't. Lycoming created magnesium cases. Then they came out and said, wait a second, our engines are lighting on fire. There's probably a potential safety hazard. So they covered that. The other part that they covered was when their crankshafts, which they sent to Brazil, and then Brazil company, who made the crankshafts for Lycoming, changed one component, one molecular component, and all of a sudden, the first, I don't know, 200 or 300 hours, they were shredding apart. Recall. Other than that, it's on the owner. Rarely do they cover it. So Beechcraft came out with this grand design that said, you know what, we need to add an STC called a metal bracket. And so what this did was it ensured that the wing root would actually stall and you had control during the stall. So it's called a stall strip. Stall warning horn, but there's a stall strip. Sometimes they were round and cute, sometimes they were L bracket. All right? Yes. Here we go. All right. Control, okay, versus Beechcraft, where you fall out of the sky on a lot of the aircraft, okay, they're just telling you that even at the slowest speed possible, you still had aileron control because of the discontinuous leading edge. Why do they call it discontinuous leading edge? I don't know, because step wing sounds a little weird, okay. So let's call it discontinuous leading edge. All right, we have vortex generators. ST seed. Sam, can you step into my office? If you're looking at my computer, right here is one little VG, right here. Often referred to as VG, vortex generator, okay? And there is a problem with these, okay? They fall off, especially when, you know, kids are around playing around with them. I'm just kidding. Anyway, so they come off, and there's a certain amount of leeway that you're allowed. Okay, one comes off, stick it back on. One comes off in flight, you don't have one. Is it still airworthy? Sometimes they allow you to go without one, but most of the time it becomes an unairworthy aircraft because you've lost one or two VGs. Bummer. Bummer. So you've got to replace the VG. Okay? Because it becomes an airworthy issue. It was STC'd with that. Okay? So you either remove all of them or you replace the one or two. It's not a cheap expense here. So here, you're asking me, well, how does a vortex generator really help? Okay? Here we go. So we have smooth airflow on a normal wing. And then with a vortex generator, you get this swirling effect. Woo! Okay? It doesn't actually make that noise. Did you find it? It's in my top, right here. Bam! One little cute one. It's all right. I'll get it in a minute. All right. Oh, please don't. Yeah. Just you need to look. That's it. All right. So it will actually help to spin the airflow over the top of the wing. It doesn't reduce your cruising speed, even though you have some type of induced drag now. It actually helps to spin, helping at even a higher angle of attack to maintain what? Your boundary layer. Okay? So here's our crazy, sometimes looks like our brain juices right there. Okay? But vortex generator actually helps to maintain the boundary layer even with increased angle of attack. Other types, we have stall fence or wing fence. What's the purpose of a wing fence? Sometimes stall fence, I think, yeah. Stall fence. What do you think the purpose of this is, Mr. Peak?
To keep the entire wing from stalling.
Not the entire wing. What portion of the wing do you want to prevent the stall early on?
Outside.
The outside. So we're going to put a wing fence, and it's typically between the wing, oh my word, between the flap and the aileron on the wing. And usually about where the strut is, so we have the exterior portion of the wing stalling later than the wing root. The wing root needs to stall first. Yeah? Very good? Everybody got that? Okay. It's designed to maintain chord-wise airflow and prevent span-wise airflow. So we don't want the air to spool off. We want it to stay pretty close. That way we get control over our ailerons still. Yep. Okay. Let me show you a couple pictures of some crazy ones. Okay. Here's another one, a gap seal. Anybody ever installed a gap seals? Okay, a lot of pipers like to install these, and all it is you notice this cute little aftermarket, like 1.5 inch extension. Okay, no, it's not cheap, but what it does is it'll prevent airflow from catching on. Okay, just smooth out that airflow, and the pipe, pretty common on pipers to add that gap seal, so that you don't get. You're basically alleviating this gap from here to here. Okay? Yep.
Why would that just be a factory?
Because in the 60s, they didn't care.
That's the way it is.
Just, well, not only that, but remember, airplanes were not designed originally to last that long. But now, here we are 80 years later, we're still flying 1940s airplanes, maintaining them as mechanics. Okay? And in this case, ours is, BA-28's 60s, so we're 60 years old. All right. Josh, I got one for you. Ready? Yes. All right.
Hi, I'm Eric Bain, Curator of Aviation here at the Intrepid Sea Air and Space Museum, and today we're going to look at one of our more interesting airplanes in our collection, one with significant history to the Intrepid, and that's the Vought F-8 Crusader. The Vought F-8 Crusader was developed in the mid-1950s as a single-engine air superiority fighter for carrier-based use for the U.S. Navy and for the U.S. Marine Corps. At the same time, the Navy was looking at the F-4 Phantoms, and unlike the Phantom, the Crusader had internal guns.
This issue was hotly debated among designers and planners, but the pilots that would fly the jet liked having the option of guns.
One of the most unique features of the Crusader was its variable incidence wings, you can see here. Now you can see that the wing is actually popped up. That's changing the incidence of the wing, or the angle to the fuselage of the airplane. And what this does, when you want to fly slow, like on a carrier approach, you want to probably fly at a higher angle of attack. The problem is with the Crusader, at a higher angle of attack, the pilot really can't see over the nose. So by popping the wing or changing its angle of incidence, we get more lift and the pilot can control the landing.
The Crusader was capable of speeds up to 1,300 miles per hour and could carry 4 AIM-9 Sidewinder air-to-air missiles in addition to the 4 20mm cannons in the nose. The last F-8 used in U.S. Navy service was an RF version and was retired in 1986, almost 30 years of service for the type.
For more behind-the-scenes videos, visit intrepidmuseum.org.
All right, so the Crusader aircraft do have changing angle of incidence. Crusader is one of those. Later, it was changed to what? You may remember what it was changed to? What aircraft came out later? Because the Crusader was eventually said, oh, we need a more maneuverable airplane. So they came out with a smaller version. Is it called the Skyhawk? Is that what it was called? No, Skyhawk was, so it was like an A7 or LVI. The LVI A7 came out and it could carry. They actually moved. Let's go back to the picture here. I know this is like useless, has nothing to do with a whole lot, but it's still cool.
Hi, I'm Eric Bain.
Okay, so then they ended up moving the cockpit up to the front, so they quit the pop-up wing, even though pop-up wing was super cool. Okay, so the pilot could actually see what he was doing. And then it carried more missiles because more missiles are always cooler. So, yeah.
Bain, Curator.
All right, wingtip vortices. I am passing around the vortex generator that Sam couldn't find. Anyway, so vortex generators passing around. That is one expensive little piece there. I'm curious what they'll cost now. I bet they're like $100 for that little guy. Super expensive. So wingtip vortices. What happens? What happens with wingtip vortices? What's actually happening? You're getting high pressure air spilling over to the low pressure side, right? Okay? And so we're getting this spillage, and it becomes where it's slipping over. We get this, our pressure that we really want for lift is spilling over the side, okay? And it can create a circular pattern, okay? Something like that. Boom, spillage over. Okay, and it affects our smooth airflow. So we got really smooth airflow over the top of the wing, but then as air spills over, it messes up our smooth airflow and our boundary layer, okay? So we can get sinkers because of that, because our lift is slightly destroyed, and what we call mushy controls. the word mushy with your students? All right. What is a mushy control? Soft. Yes. Ineffective. Feels very ineffective. You notice with the Kodiak where he was, you know, it's not his plane, he's just the pilot. So he's sitting there yanking all the control back and forth at a stall speed. And what was he selling pilots on, owner operators, whatever, was the fact that he did not have mushy controls. He was very sensitive still at a very slow speed. Typically with smaller general aviation aircraft, and I don't really know because I haven't flown like a beach jet or anything, so I don't know what it's like, and I don't think they usually fly those at stall speeds. But on the smaller general aviation aircraft, you'll get really, really lethargic and slow, insensitive, or ineffective flight controls where you're sitting there. And what's the problem with that, Trevor? Yeah, oh no, I can't get on center line. I can't line up. And so they're really insensitive, real lazy, and makes really delayed corrections. Yep.
Your VGs are 157
Each.
I can buy a whole STC for 1,500. That's worth it. On aircraft cruise.
Send it, man.
Send it for
Yeah, especially all the money you just saved on your on your Chevy Cruise, right? All right. Okay. All right, wingtip plates. Besides looking cool, right? Yes. We're gonna put this on the back of the Hummer out there, right? Okay. All right. So what do you think the purpose of wingtip plates are? Yeah, you don't want to get the air to spillage over, right? We don't want to use spillage. No spillage here. We're going to keep the air. So they got vortex generators, which, you know, at this point, it's like, whoa, he's spending more money on the STC than it is on the aircraft itself. So we got these wingtip vortices here, vortex generators coming over the top, and then you got a wingtip plate. Wonder if it even had a wingtip wing fence. But here's some wingtips added on. Down at Duncan, I have a friend down there. Well, actually, I think he just broke up with him after 15 years. His name is Miguel. Miguel's an airframe guy. He was quality control and also supervised the airframe guys at Duncan. And he said they were having to add these, and I can't remember what aircraft he said. Did he say Falcon? I can't remember. They were having to add the wingtips because of such violent stall characteristics. It didn't actually stall, but it was super spongy or mushy at slow speeds. They're coming in, they're having to slow down. Maybe traffic's on the runway, and he said that the pilots were saying, man, I am not getting controls at slow speeds. So what they did was they actually had to come back and weld some of the components together, and then they would get it on there. And they would fabricate those even at Duncan. It was an STC. They were allowed to do it. But he's like, you know, we do use welding. We use TIG in our shop. Because I was curious, like, hey, do you actually use TIG on the corporate level? Oh, yeah. Yep, I have my guys learn TIG. So it's a valuable tool to have. And so he was talking about those specifically, the way they set up the bracketing for the wingtip. All right, winglets are just cool, yeah? Come on, super cool, right?
You have the boring one, though. This is old.
All right, what about that one? That one's cool.
No,
Okay.
that's nice.
All right, that one's not cool, okay.
With the fins coming off the bottom, too.
That was the first picture.
Yeah.
No.
Yeah, fin coming on the bottom.
That's
There
a
you go.
319, 320. The next one is like a Boeing style.
Okay, whiner. All right, let's move on. I was trying to be cool, and then Zach's like, you're not cool. You're so like last year. All right. Well, let's step back in history here to the VTEL Bonanza, and you can add these wingtip tanks to it, okay? Super cool, except to Zach. So, this is a 3 window, so it'd probably be late 50s, early Wingtip tanks, get 6 hours of fuel on board. Kind of the retro color there. If you paint a detailed Bonanza, please paint a cooler color than that. All right. Drooped wingtips. Drooped wingtips. Well, what's the purpose of a drooped wingtip? What do you think? Prevent the high pressure from spilling it over. If you've flown a Cub with standard wings, you'll soon get the feel that, oh, the wing aileron, or the ailerons are so mushy at slow speeds. Okay? Now I know this is not a Cub here in the picture, so they would extend the wings and then they would throw these wing tips on it to give you solid fill with without the sink rate going way up. So what is this? What is a sink rate? How do you explain a sink rate? So you're coming into final, and you can catch a sinker. So sinker, you're just going to start sinking, literally, depending on temperature, your pressure. There's a lot of variables, but you catch a sinker, and if you're real low to the ground, it could actually slam you into the ground. Okay, a friend of mine flipped a 180, came in, tall trees, 75-foot trees. Comes in on final, he gets over the trees and sinks down over the grass strip. And he said immediately he had a sinker, added power, and he said, man, I knew it was too late. And so it actually rolled the 180 over. High time pilot, very high time, I'd say 22,000, 25,000 hours. So it's not just a joke. He came in and he said, man, it was right over. As soon as I got over out of the trees, I caught a sinker. Yep.
What'll cause that?
Well, in this case, it was probably just dead air right below those trees. But it could be wind shears or different high pressure, low pressure. Man, it's a lot of things. You know, mountains, flying over mountains, you'll catch those oftentimes. You'll go over a mountain, get a riser, and all of a sudden, coming on the other side, you get a sinker. So, but it's dangerous close to the ground. Yep. Anything you want to add, CFI? Yep, double I, sorry. Anything you want to add? All right. No, that's pretty good. All right. Okay, another term for mushy is soft. Soft ailerons. Soft. All right, Corbin, this is for you, buddy. Okay, we got canard wings. What do you see is missing? A rudder and a vertical stabilizer. You got a little stability out there on the tail. So I had to do a little search because that's just me, a little nerdy. And boom, there it is. You see it? Whoa, hanging down below. It was like an afterthought. You know what? Let's just throw it on there. The whole thought there is like, does the pilot supposed to flare? How does that work? If he flares too much, she flares too much, whoever, flying the plane, flares too much, might have to do a little structural repair. Okay? So this is what I was talking about is, look at your controls here. So you got aileron control, but what in the world's going on? We got a flat track here, but it looks like we even have a control here as well. Like an elevator style control. Yeah.
Related to the controlling.
Is that what you're going to say, Josh? Okay.
No, I was wondering what you think the little thing in the middle of the wing is. That's just like a
Right here, boss?
stabilizer.
Right here?
Yeah.
What do you guys think? It's a type of fence, but they got to put a biggin on it. Yep.
Rudder on the wing.
Yeah, that's your rudder controls on the winglets. Pretty wild. Anybody buying?
Well, look at like a Piaggio, I think it's similar, those are becoming popular. You know
Sure.
what a Piaggio is?
Yeah, I do know, but we don't buy things because they're popular, but yeah, sure.
Isn't they cool?
All right. I have no idea, buddy, but I know probably like 6, 5.5 or something. Okay, T-tail. Okay, there's a screamer, hauler, right? What is it? Hey, there's nothing wrong with that. They got more power, less drag, right? So let's just, hey, if in doubt, throw another engine on there, right? So they threw 4 engines on it. Now it's a screamer. And we got a T-tail, okay? What was the purpose? What did the short guy mean? Say the purpose of typically was of a T-tail? Yeah, a little bit more stability in flight because you have what? Undisturbed airflow, okay? Unless you get into this attitude. Okay? Normal flight, super cool, okay? Smooth airflow over the wing, smooth airflow over the tail, lots of room for the engines to get good airflow, and then all of a sudden, now we're in the shadow of the wing, okay? You decide to, they say, hey, climb and maintain 20,000 feet. You need to step it up. So now you're going to step it up to 20,000 feet quickly. Now my tail has extra disturbed airflow. Extra disturbed airflow. What's the problem with that? Any problems? Anybody foresee any problems with it? Yeah, you have high probability of losing a boundary layer over the elevator. Okay, because it's disturbed airflow. All right, everybody good? All right. Okay, this is a sales pitch. I'm not trying to sell you on a Kodiak. It's just real world stuff. So. All right, so I'm just going to go through, let you watch how he goes through these components. Realize this is a pilot talking. He does pretty good job. You'll catch a few mess ups where he calls something the wrong thing. It's okay. In your mind, you already know how to correct it. Okay? Oh, thank you.
Hey guys, Mark Brown here. I am the Chief Demo Pilot and Director of Marketing for Quest Aircraft Company. I'm here in front of American Kodiak, one of the Kodiak dealers, our Kodiak dealer here for the state of Texas. I'm here with their airplane, and today we're going to do a walk around of the Kodiak 100 Series 2. So we're going to start up here with the very front of the plane, the propeller. So what we have here is a 96-inch Hartzell 4-bladed prop. What makes this prop so great is the clearance it provides from the ground. So it's got 19 inches of prop clearance. The Kodiak was designed as a modern day bush airplane. It was designed in the late 1990s, early 2000s because there was a need. There was no airplane that ran on jet fuel that had a turboprop engine that was really designed and built to go off airport and into the bush, if you will. So everything around the Kodiak is designed with that mindset. This is the best off-airport bush plane made, but it's also, you can think of it kind of like a Range Rover or a Toyota Land Cruiser with wings. It's a very refined luxury SUV, but it has the brawn and the beef to go off-airport. So that 19 inches of clearance is extremely important. It obviously is fully feathering reversible prop, so you can use the reverse thrust to help you stop even quicker on takeoff, or on landing, excuse me. Coming back from there, you'll notice this air intake is very high off the ground. Again, done for the purpose of off-airport type operations. It also cants up just a little bit, and again, that's for FOD on takeoff and landing, so FOD doesn't come in. We actually, inside of the takeoff of the air intake, is what we call the inertial separator, which is a way for the airflow to actually come in the engine, go down, and then it has to come back up. So in cases where we're landing on very loose gravel type strips or flying through heavy precipitation or ice, That way the airflow does, or the FOD goes out the bottom of the plane, and the air is the only thing that can make that turn. The engine we have behind this cowling is the PT6-34A, or -34, excuse me. It creates 750 horsepower. One of the reasons that we picked this engine, number one, it had the horsepower rating that we needed for the airplane. Number two is it's one of the most widely produced PT6 engines. So from that standpoint, there's a whole lot of them out there flying. There's a whole lot of parts availability for them. They're very reliable. So what it allows is the cost of operations of the airplane to be significantly lower than any comparable single-engine PT6. One of our first customers was humanitarian groups, and obviously they count all their pennies because they work on mostly donations. So a low cost of operations is very important for them, and of course for your average owner-operator or commercial operator that might use the Kodiak, the lower the operating costs, the higher they can, their profit margin will be. Coming back from there, these are exhaust stacks built by Frakes Aviation here in Cleburne, Texas. They're designed for the Kodiak. They give it the right, they actually add a little bit of thrust to it, and they don't impede performance, so they're great stacks specific to this airplane. Moving back, we'll get to the landing gear, the nose gear. So the nose gear on the Kodiak and the landing gear in general is really quite impressive, and it's one of the things that makes the Kodiak very unique among its single-engine turboprop competitors. This has the large tire option, so both the mains and the nose wheel have the large 29-inch tires. The nose fork all the way up, if you took this cowling off, it's really impressive just how much structure and rigidity there is in the nose gear. As you can see just by looking at this torque tube and just how thick it is, it's really quite impressive. So one of the things that we say, this isn't an FAA regulation or anything like that, but the gear is rated to a 9-inch stump load. So in essence, the gear should be able to hit a 9-inch tree stump and I'll be okay, which is pretty impressive if you think of just how tall a 9-inch tree stump would be. Normally it would shear the gear off of a lot of airplanes. Moving a little bit further back, I'll open the engine cowling here so we can have a look at what's inside. So it looks pretty standard to a typical PT6 installation. What you looking up here, so the gold is the 300 amp starter generator. That's standard equipment on every Kodiak. We have an alternator here. We have, this airplane has the optional AC, so it's an engine driven compressor that we have here. Here we have the oil cooler, so that's what this NACA duct is for. This cools the oil obviously going to and from the engine. This is our brake fluid reservoir, so it's about the only hydraulics on this plane besides the TKS anti-icing system. Close that up. The great thing about the Kodiak from a maintenance standpoint is all the maintenance on this plane is very easy and
Sign up for the PF Flat Card and get your first month free. $1 down, $24.99 a month. Deal ends March 13th.
So moving back, there's not a whole lot on this side, but I will point out right here we have a lot of people ask what this light is for. Well, this particular airplane is equipped with the TKS anti-icing system. And this light is your ice light, so when you're flying at night, you can turn that on. It shines a bright light on the leading edge of the wing. And of course you can see if you're building ice or not at night. You can see the TKS system here on the leading edge. So it's this titanium, there's tiny little microscopic holes all along here. Pretty interesting thing is we have TKS on our struts as well as our wheel fairings. A lot of people wonder why. There's kind of two reasons. These are obviously big, large surfaces that will build ice in heavy icing conditions. They're also airfoils, so technically they're a type of a lifting surface. So we have to obviously have ice come off and cannot build on any lifting surface of the plane. So as we work out, the wing design of the Kodiak is probably the most unique feature set of the airplane. It's what during R&D, during our developmental process of the plane, we spent probably the most time and money on. And what makes the wing so unique is a couple reasons. Number one, it's a high coefficient of lift wing, which basically means it's a very thick wing. So it produces a lot of lift, which is part of the reason why it's such a great STOL plane. It also allows the plane to build ice and be very safe in ice. We did icing testing to various levels of ice buildup. The Kodiak never was in dire straits. It was never, falling out of the sky like some other airplanes are known to do, from piston all the way up to multi-engine airplanes. So you can get a lot of contaminants on a high lift wing and you still create a lot of lift. The really unique part about the Kodiak wing is above me here. So a lot of people notice, because the only real way to tell is what we call the discontinuous leading edge. So the discontinuous leading edge is the marker actually for a different airfoil which starts here at rib 13 and goes outboard. What makes this wing design so unique is it theoretically makes a unstallable wing. So on a straight wing airplane like the Kodiak, the stall starts at the wing root, works its way out, and then eventually gets to the tip. And anybody that's ever flown an airplane or done flight training will know that when you stall an airplane, typically one wing drops before the other. And the only way to get out of it is by adding power and pushing the nose forward to get lift back on the wing. The Kodiak wing, what happens is in a flaps clean situation, so flaps 0, the stall will stop right here and this outboard wing will never lose lift. So if you notice, the outboard wing lines up perfectly with the aileron. So if you have lift going over this section of the wing, you have full aileron control through the stall. What that means is I can sit with a Kodiak with a power off situation or a 0 thrust rating. I can sit there with a stick all the way back in my belly and I have full aileron control through it. So the Kodiak will never drop a wing that's unrecoverable during a stall, which means during the most dangerous phases of flight, when you're slow speed, you always have aileron control. That was done for a number of reasons, but first and foremost is safety. We believe the Kodiak is, with its modern certification, 2007 Amendment 55 certification, is one of the safest airplanes. This wing obviously makes it even safer. So moving back inboard, a lot of people notice these flap tracks. So these flap tracks are really unique, and I like to point them out because it's one of the very obvious signs of just how robust and well built the Kodiak is. So if you notice, if you get up real close, these flap tracks don't have any weld marks in them. They're machined out of a solid block of aluminum for strength and quality efficiency, or quality control. So it's the strongest way to build a flap track. And as we all know, the flap tracks aren't particularly under a high stress load except when the flaps are out. So if the flaps are made this well, you can see how well everything else is made on the plane. There's 3 flap settings on a Kodiak. There's 10, 20, and 35 degrees. Every Kodiak takeoff is done with 20 degrees of flaps. Every Kodiak landing, well, you can do different landings, but recommended we typically land with full flaps at 35 degrees. One interesting thing that I like to point out is this is a pretty neat feature, especially for operators that are doing high load, low fuel type situations. So what this is a fuel dipstick. So I'm just going to break it free from its magnet, And as you can see here, there's different fuel levels. So if I push this up, right there, it stops. So if I look here, I have about 425 pounds of fuel in this wing. That's a really easy, accurate way for me to check the fuel load in the wing without having to crawl up on top, and it gives me a way to verify, because everything in flying is always double check. So obviously my avionics is going to tell me how much fuel I have, but I want to double check, and this is a very easy, simple way for me as a pilot to double check how much fuel this wing has. Moving down here to the landing gear, as I mentioned earlier, these are the 29-inch larger tire options. They look pretty small when you see the Kodiak, just because the Kodiak's such a big airplane, but you can see here it's a pretty substantial tire. The cool thing with the landing gear and the tires specifically is they were certified to a lower PSI. So one of the big problems with bush planes, or airplanes that have been adapted to be bush planes that maybe weren't designed that from the start, is the tire pressure tends to be very, you actually have a certified tire pressure range that you can be in. And a lot of those tires are too inflated. They're too much PSI in them. So when you get onto a soft strip like this, what'll happen is the tire will actually rut out, sink in. That can be really dangerous in a takeoff or landing scenario, because one tire might rut differently than the other, which could pull the airplane off the runway one way or the other. The Kodiak tires were certified to a lower PSI, so it will actually float on top of a soft type surface. So again, just the Kodiak was designed from the ground up to be a modern day bush plane. So even things like the tire PSI is designed for that type of mission. So how the Kodiak, I talk a lot about the modern day bush plane, and it's great if you're flying into Papua New Guinea or Amazon and the Amazon. But for instance, here we're in Texas tonight, and we're here at a gentleman's 600-acre ranch. He lives about an hour-and-a-half drive from DFW Airport, or one of the major, Dallas Love Field or Fort Worth Meacham. What's great about the Kodiak and how this stuff translates to your everyday, maybe high net worth purchaser is the Kodiak can be supplemental lift. So you can never fly a jet into here, but maybe a customer might have a jet flying to and from, Dallas to Los Angeles or Dallas to New York, and they still have an hour-and-a-half drive to get back to their home out here in Northeast Texas. So the Kodiak can go to Love Field and in 11 minutes pick them up and land here at their 1,000-foot airstrip outside on their 600-acre ranch. It's all done obviously in very safe, luxurious configurations with the Kodiak. So a lot of people say, well, all the bush and stole is great, but how does it benefit me as just a private pilot or owner-operator? And it has a lot of uses, and it's, a helicopter could do the same thing, but a helicopter is 3 times as expensive. So this is a more economical way to get to and from your back door without having to drive anywhere. So moving on, I wish when I told people this, the fairing wasn't here, but to continue on with the landing gear, what makes the Kodiak really specific is the wing and also the way the landing gear is designed. So if we took this fairing off, you can kind of visualize in here is a solid steel, what we call a solid steel trunnion, and you can see the rivet lines actually go up, and this is in line with the rear spar of the plane. So the wing, the strut, the landing gear is all connected, and it's all designed to be extremely robust. So there's no, you're not going to shear the landing gear off on a Kodiak. You're going to, it's always going to be there, which we believe is the safest scenario, is to always have your landing gear. You don't want one of them to, after a hard landing, land and you're flying down the runway. But even at those speeds, you have a ton of margin. Working our way a little further back, a lot of people ask what these are for. This is part of the air conditioning system here. We have a rear evaporator for the rear passengers here. Moving.
For the Kodiak, I know we went through the 34 series PT6, but when we get into turbine engines, I don't know if Christine will talk about that. you actually have to increase the horsepower when you put an air conditioning system on these aircraft. For example, when the MAF aircraft comes in, the only aircraft they have air conditioning on is the one that they visit all the schools with, which is coming soon. And they actually have to jump up the horsepower on that particular engine because the AC, when it's running, sucks down some of the power. So, anyway, then of course, they cut huge holes in the side of the plane.
So do they turn the AC off on the landing, or taking off?
I don't even think they have to, because they have to increase, it takes like 45 horsepower from the engine, so those engines are already derated, so they just jack up the rating back up. Yep.
Coming up, obviously you have your new, this is a Series 2, so we have a Series 2 paint scheme on this Kodiak. The NACA duct up there on the dorsal fin, that is for fresh air intake. This is the ELT antenna, the big white antenna you see here. Moving a little bit further back, a lot of people wonder what these are for. These strakes are, you'll only see these on airplanes with a cargo pod or with floats. And basically what they do is there's a little low pressure system that's created back here in flight with the cargo pod. And these kind of reach out to grab the air. You'll see these on other airplanes, especially jets. Like if you look at a Learjet, they've got pretty big rear strakes. So they're pretty common. They just stand out a little bit more on the Kodiak. Moving back, you'll notice the vertical stabilizer and rudder are pretty big. And that is because we have a ton of horsepower in the front. We have 750 horsepower. A lot of people call us a short coupled airplane. That basically means from the tip to the tail is shorter than a normal airplane, if you will. And that's part of the need for the large vertical surface and large rudder, is just to have that full control when you're full power on takeoff. The elevator and horizontal stabilizer, nothing great here. You'll notice it's pretty wide. So as the CG envelope of the airplane increases, the wider the horizontal surface has to be. So the Kodiak has obviously a very large CG envelope, so that's why this tail surface is so wide. Back here, I'll make note of the trims. So the Kodiak, being a modern airplane designed in 2000 or certified in 2007, the trims, all three trims, aileron, elevator, and rudder trim, are all fully electric. So there's no old manual gear levers that you have to move to do the trims. It's all nice electric switches. This is the elevator trim tab right here. Moving back, not a whole lot to see. You will notice there's VGs all over the plane. VGs are these little strakes right here. They help with slow speed and sometimes high speed flight. It basically grabs onto the air and sucks it back in. It's part of what allows the Kodiak to be such a good slow speed, short takeoff and landing plane. Moving up here, we'll get to the back door.
He's going to go through the interior styles that you could purchase with your next cheap jet instead of the expensive jets. For those of you who have high net worths. Okay? Take a 10-minute break and come back. Turn the record back on. Control surface balancing. What are we doing here? What's the purpose of having a balanced control? Nate, tell us.
Stable flight.
Stable flight. Good. Nailed it. All right. So rigging and proper component balance, the potential risk of flutter, and then steps to balance the control surface. Sorry about that. Got a word. Okay. Students understand how the risk of flutter or unbalanced control surface potentially dangerous to you and to the passengers. Students should have a basic introductory understanding of how to balance the control surface. So today, you're going to balance the control surfaces that you removed. Okay, that's the goal of this afternoon or this morning. And then we'll come by and we'll sign you off. I want everyone to be able to balance an aileron, an elevator, and a rudder. Okay. Now you're going to have to share the rudder a little bit. Share the wealth. Okay. All right, I'm not going to hit any review questions questions so far? Yeah.
So like, when you'd actually, balance control surface, is that when you're either replacing one damage, fixing one, like what would be a scenario where you're actually?
Sure. So balance would be necessary when you paint. If you have loose rivets, you gotta re-rivet it. Typically that you don't need to, but if it's a loose rivets with the counterweights, okay? That's pretty common to have to, okay, I need to make sure that we did it correctly, it's rebalance.
Is that something a pilot would like come when you recognize that it's like going well?
Yeah, yeah. For example, with the 182 that they sold this year, the 180/182 conversion, the ailerons that we have on our 182, they noticed never seemed to do align correctly. They all had a slight droop to it. And then they got investigating it and realized that they were not really for a 182. They were for a L19. So they took the ones off our 182 because it's 2 years different, same part number. So they tried to balance it and realized it was not even close to a 182 balance range. Okay? And that's when they got investigating even further. So what's the importance? Why do I need to do it? Does it even really matter? I'll show you some, a couple accident reports and a couple crazy videos of test pilots. Okay? So, can you see this? Those of you who can't see this, I'll try my best to read it. And hit the highlights. I'm not going to read it verbatim. So, on April 8th, 2017, about 20:56 Eastern Daylight Time, a PA-12 was destroyed by impact and a post-crash fire after takeoff from Orlando Sanford International. The airline transport pilot was fatally injured. So what do you already know about this guy? Dead, and what else? He has an ATP. What does that mean? You got a lot, pretty good amount of time, okay? So we have visual meteorological conditions, or VFR, prevailed, and no flight plan was, so more than likely it was just a sightseeing flight, okay? According to the review of preliminary air traffic control communications, pilot received the takeoff clearance for runway 27L. Left. A witness to the accident recorded the flight on his cellular telephone. He provided the video and gave a statement to airport police. According to the witness, the airplane accelerated normally for takeoff, pitched up and continued to pitch up into a full stall, rolled to the right, and then nosed on the right side of 27L. Okay? Notice the next line, the next yellow part right here. The accident flight was the first flight following a 2-year restoration of the airplane that included replacement of the wing fuselage fabric, flight control cables, and electrical wiring. Anything leading in yet? Okay. Airplane came to rest, inverted, oriented on a magnetic heading of 170, so almost south, in the grass about 9 feet north of runway 27L, adjacent to the 1,000-foot markers. So all flight control surfaces were attached to the respective attachment points, which is good to know too. The left and right aileron cables are continuous from the joystick to their respective bell cranks. Rudder cables were continuous from the foot pedals to the rudder bell crank. Manipulation of the elevator control cables revealed that a nose-up control stick input resulted in nose-down deflections. You pull back, and where does the nose go? Down. Further examination revealed that the elevator control cables were improperly rigged and said that they were attached incorrectly or opposite locations on the upper and lower elevator control horn.
That's pilot's fault.
I'm pretty sure in this case it would be the restorer's fault.
But he had to go.
Who signed the aircraft off, Zachary?
Mechanic, but it's always the owner operator's fault.
Nope. Yeah.
In your, op check review that, or when mechanics sometimes actually take aircraft as well?
No, the mechanic is not technically allowed to take it for a flight. He's allowed to taxi and run it up. Can't take it for a flight without the owner operator's permission, right?
But you're, okay, even if it's not taken for a ground check, would it be?
I sure hope so, and so would a pre-flight. But that doesn't matter. Somebody signed it off as airworthy. Okay.
Then my question is, like, goes back to the last class of airframe inspection. If a mechanic signs off the aircraft as airworthy after $100, not all the AVs have been technically complied with, it's the owner operator's fault. Like, if they go fly the plane, not all the AVs are complied with, but the mechanic still signed it off. That was the question that we were asked.
Okay.
So then, in this case, wouldn't it still be the pilot's fault for improper pre-flight?
Who rigged it?
Mechanic,
Who signed it off?
mechanic,
Who's gonna get burned?
this case, be the mechanic then. But
Sure, the pilot might have got a violation, but the mechanic's gonna get, he's gonna get several violations on that one. Okay. All right, point being, it's very, actually, it's a very easy, now that you have your rudder controls off, all of you have removed your rudder controls off the control board. It's actually very easy if they go back into the tail section, then when you pull them, that they could actually either come off the pulley and go to the wrong side, okay? Or they could simply come off the pulley. Yep.
It's like in this situation, like, you file off the license, and fine, done with our aircraft, so I put it in.
No, no, it wasn't, I doubt it was malicious. It was just mechanic's fault, so, no, they wouldn't.
We have to put tail down on that for,
No, unless it's malicious. Not sure business would be,
at what point could it be considered an alternative negligent flight? If they had trouble the week before and they got in an argument.
so, not necessarily, but if you have a history of stupid mistakes, or you did it unsupervised, and you're supposed to be supervised, then you probably could get in trouble for that. But if you just simply made an error like that, probably just gonna get a violation. But still doesn't alleviate the problem here. The problem is they didn't do a double check. They didn't have a series of double checks in their shop, because that should have been easily fully yoke back. Bam! Yep, elevator comes up. Right? Oh, sorry, stick, yep.
so then what kind of repair would require to be done? What kind of repair would require?
When the manual tells you, but you still can't fly it. And without, number one, insurance telling you can, or that you're type rated, or not type rated. You're rated for that aircraft, yep. Most of the time it's gonna be insurance. Hey, you gotta have 50 hours in this specific
Well,
aircraft.
you, I'm just saying that's not true.
Yeah.
I just, it's usually like,
Flight controls, and if the manual told you on a PA-12, I doubt PA-12 would tell you to test flight, but some of the Pipers would tell you, like the newer styles, say, hey, go out. After test flight, come back and we can't do another reading. Okay, all right, so another big hot topic is runaway trim. So this is on airlines, I think it's specifically the Embraer, so let's take a gander at this real quick.
Pilot Institute is educating the next generation of pilots. With more than 15,000 five-star reviews.
Okay, so we just took off from SeaTac, and it's a great day because just whipping around the pattern visually. Came up to 6,000 feet. Now here's the one thing that you've been hearing about with this whole max thing and all that is this trim runaway. So you never know. Obviously, to these guys, they didn't know when it was going to happen. And what happened is they're cruising along. All of a sudden, boom! You're like flying along. You're like, what's going on? 1, 2. What is that? What is that? And you're like, that trim's run away. Stab cutout switches. It's the only way to get rid of that. That's what disconnects the motor from the vac to the stab system. And I don't know why we lost so much. I guess the trim ran away there, so we just lost 5,000 feet. Fortunately, we're the only guys in the sky today, so we're able to do that. But anyhow, that's what got those. I think that's what got those guys. Again, because Boeing put those monstrous motors out there, and every time you add power, it made the nose wants to pitch up. That system would make the nose pitch over, is my understanding of it. Again, I haven't done a whole lot of reading about it, but that seems to kind of what it came down to, was that the system thought the airplane was climbing and the trim started running nose down, meaning it's going to want to shove the nose down to go counteract the nose up tendency of those big motors, and it just kept going down and down and down. I thought I had heard that one of the group had actually shut it off and then was able to regain control, but then subsequently turned it back on and went in. So again, yeah.
Okay, so runaway trim doesn't have a whole lot to do with us as mechanics and how to override it, except for you and I are the ones that have to fix it, right? Okay, pilot complains of runaway trim. Please don't dismiss it. Okay, there's obviously a computer malfunction here. Okay. All right. Okay, here's an NTSB report, runway trim, brickyard. Let's go ahead and skip this. We'll come back to that. So what's the purpose of control balancing? A control balance that's out of balance is unstable and does not remain in a streamlined position during normal flight. It has a negative dynamic, okay? So meaning that once it starts, potentially, it's going to get worse and worse and worse, okay? Flutter, the rapid uncontrolled oscillation of a flight control surface on an aircraft caused by dynamic unbalanced condition. Okay, please take that into mind, okay? You run an aircraft and get a little bit of flutter, it's a big deal, okay? Pilot complains, man, I feel like my horizontal or my elevator was a little bit unstable or vibration, okay? Flutter gets significantly worse at higher airspeeds. Flutter normally causes the loss of control, loss of the control surface and a crash. Can progress at a fast pace that the pilot has very little chance of recognizing it and responding. Yes, Isaac?
So is that in relation to how much, like, if you're barely out of balance, is it going to flutter less than way out?
That's right, correct. And I have several videos here where it gets, it's like eye-opening, just how little it takes. Okay, this is NASA. This is in a wind tunnel. Okay, Josh, this is for you, buddy. Okay, are you with me? Hold on with me. Here we go. They're actually going to destroy stuff. How much does it take to hold on? So this is a little...
This is a full-size air.
No. This is a scale one in a wind tunnel. But they're trying to see how much it takes. Okay? Oh, it's gone. There it goes. All right. Now we're going to lose, not lose, but, well, we will lose. See ya. Okay. Here goes tail section. All right. Oh, we're losing skin. There we go. Oh. Oh, it did stabilize, right? No, they pulled the throttle back, right? Okay, this is hard to see, sorry. All right, here's our wind tunnel, tail section gone. Next one. All right, here we go.
Travel, one little word that means the world to us. Trafalgar doesn't just take you places.
Okay, you're gonna watch specifically the horizontal stabilizer here. Please focus. Yeah, there you go. Okay.
Replace that after the test was.
Say it again.
They replace that after the test was.
Oh, I hope so. All right, this is a great one too. Flutter. What is flutter? Great. There's the same picture there of the Seneca. Man, that's crazy. All right, now watch the wings on the glider here. We're working on it. Here we go. Oh yeah. Get a vibration range here. You watch it. This is the one that gets vibration range. Yes. Oh yeah.
Is that unbalanced or like overspec?
I have no idea. Oh yeah. I think you got a problem. Watch it. Watch it. You see it? Oh, please don't come off. Please don't come off. Okay. Hold it. Hold the camera. There. Hold the camera, please. Okay. Severe turbulence, but it's okay. It'll move 30 feet. Vortex generators out there. Okay, there's your canard wing. That's a hard video to pay attention to. The whole thing's fuzzy. Okay. Though they look cool, Zach, I'm not buying one. Oh yeah. Oh yeah, that's sketchy. So typically on your horizontal, you'll have 4 bolts that hold it on. Is all you have. Ooh. Houston, we have a problem. Okay, this is just an RC plane, but I'm really glad it's an RC plane. Alright, a little flutter here. Alright, kind of the adverse loading of missiles. There you go. Oh man, I'm worried.
In most cases, why is it flutter?
So typically it could just be as simple as a bolt that's missing or loose. It's not torqued all the way. Okay, because our horizontal literally only has 4 bolts that hold it on most of the time. So if you typically leave just one of those bolts out, you'll get a flutter. Yeah, crack across one of the horizontals. Vertical it was not tightened down properly, same thing. one's only very, very short, but this is a real accident, okay? He did survive it.
In the dead of night. During Chesapeake and depart the area. Stay where you are, folks. This is okay. Stay where you are.
Man, ain't supposed to do that, man.
It just took a matter of seconds. Now this is several flybys at the air show. Okay, so how does flutter happen on our small general aviation aircraft? How does it happen? Okay, do you remember the piece that I passed around, the counterweight? Okay, that was severe flutter off an aircraft on the airport here. Pilot comes in and says, man, I have a vibration in the yoke. Okay, what aircraft? He tells us it was Piper. Okay, in our mind it was like, okay, there's counterweight. Could be loose weights on the aileron, on one of the ailerons as well. Just the loose balance weights. Okay, because they're lead, then they're drilled through and then riveted, and hopefully the two brackets hold it. But it's not uncommon for them to get loose. Okay, so immediately we pull the panel off, we start grabbing stuff, and it moved. Okay? The automotive world would say what? Tighten it up. Is that what you're going to say? Tighten it up. It's a terrible idea because now the rod is sitting inside the piece of lead. The lead's actually worn. So the potential is tighten it up. Yeah, you're gonna bend the lead or possibly put the bolt in tighter into the lead, so it could crack the lead. Okay. So it's cheaper in that case, with the lives involved, just to go ahead and buy another balance weight. Okay, statically balance the control surface. What does the surface do when suspended from the hinge points? So you put it on the hinge points, and we're going to balance it. And depending, every single one is slightly different. So make sure you're following the manual. Oh man, I've got a 182, I've got a 210. 210, as I told you, the ailerons are inverted when you balance them. They have to be inverted on a 210, the 77 version at least. Tail down, under balance. Nose down, over balance. Dead level. So when you put a level on it, the back of it's down, it's under balanced. Nose down, over balanced. Okay? And it will give you a range. I'll show you that momentarily. This is your flight control, kind of give you an idea of what we're looking at. Now, is an aileron going to be balanced down the center of the flight control? No. Normally it's towards the bottom of the flight control. Normally, but not always. Okay? What about an elevator? No, it's normally going to be at a different, slightly at a underbalanced angle as well. Okay, is a rudder. Yeah. Rudder is going to be normally right down the center. Okay. Static balance can be checked or adjusted by the mechanic. Okay, you can do that. Generally, a static overbalance is more desirable than an underbalance. Generally, why is that? It gives you a range of 0 to 5. Would I rather be closer to 0 or closer to the 5? slightly, a tail heavy underbalance condition calls undesirable. So if it's slightly heavy toward the front end, is better because we get a potential of less flutter there. But our goal is to get in the range. An aircraft's speed increases, tolerances for the balance decrease. So I don't know how you teach your students. If you ever felt a flutter, what's the reaction, or what should the reaction for a pilot? Throttle back. Yeah, immediately. Straight and level, throttle back. Don't make any sudden movements, throttle back. Okay? Get it chill out and then get to safety. Dynamic balance, tested by the manufacturer during certification. So we're statically balancing, we're not dynamically balancing. Okay? You determine the correct balance. Okay? Those of you doing experimental or mental aircraft, okay? You know what Matt calls them, mental aircraft, experimental aircraft. Some of you could have opportunity to be able to play with those weights, but we are actually given the range from the manufacturer on certified aircraft. It's balanced within the static balance limits and also considered to be dynamically balanced. So, the question Parker asked, anytime the control surface has been repaired, paint, repainted, altered in any way, what's the balancing procedure? Remove it, use a suitable support stand. It must be able to rotate freely on the hinge. Make sure you get the same bolt size that's on the aircraft. So if it's an AN4, get an AN4, not an AN3. Okay, it does slightly matter because you'll get a little bit more play with an AN3. So if it has an AN4 bolt on the aircraft, use an AN4 bolt. Okay, makes sense? And if you're on the, if you don't put it through far enough, or if you get a threaded portion, that will also affect it. So it needs to be just the flat shank that's sitting on the hinge point. Okay? Always follow the manual. So our balancing method is here. You're going to take, so let's say we're using an aileron here. You're going to take it from the balance point. This looks like elevator, but say we're using an aileron. You're going to take it from the balance point. Sometimes it'll tell you on the hinge line, the ailerons for the Cessnas, on the hinge line, and it's going to tell you a certain portion. Okay, 172 says 1/3 from the bottom. What does that mean? 1/3 from the bottom of the aileron. So it means I take the measurement of the aileron, say it's 3 inches. What's 1/3 of 3 inches? 1 inch. So I come up 1 inch, and then I follow it from here to 1 inch. I put my level on the side of it, boom, put a level across the side of it, and then I hold it there. Then I'm going to take my beam, not this, sorry. You're going to take your beam, and you're going to level your beam up while you've got your aileron level here. So I've got my, this is a rudder here, but you're going to get your flight control level where it says to get it level. Okay, if it's 1 inch or 1/3 from the bottom, you bring it up 1 inch, and then you're going to bring this rod right here, your balance beam, and you're going to get it level across the 0 or wherever the hinge point is. Okay? But one thing that I've seen a lot of people do is they'll forget to balance your balance beam. Okay? So if you move this, you got to rebalance that balance beam, okay? Here we've got a rudder with the counterweight on top. Okay? Notice the counterweight. Sometimes the weights will be down here. It wants you on the hinge line, so you'll have to turn the balance mandrel here. You'll have to kind of turn it to get on the hinge point, but you don't want it to hit the 2 little ears sticking out. So make sure you get it in there, but here's your counterweight. Okay? So take all that into account when we're trying to balance it. how do we adjust a balance weight? The balance of the surface is using weights located forward of the hinge line. Most of the time, it's lead, tungsten, or depleted uranium. Yeah, so I think I got a piece of lead here off a, what? I don't have any uranium, sorry.
I was really hoping you were gonna say, I think I got a piece of depleted uranium around.
Oh, wouldn't that be cool? Where if did I already pull it out? Oh, I don't see it. Okay, so, the lead portions, they'll be sometimes this big on the front of the rudder, like the 182, 172 that sticks out. You'll have just a triangular weight on those as well. Make sure you follow manufacturer's instructions for adding and removing weight. Sometimes they'll say, if it's overloaded, just drill it. But then to add it gets a little tricky, okay? Because you want it tight. The weight has to be tight. And then inspect the security of the weight. So I've seen DMEs loosen some of the rivets, and then they'll rebuck them, but they won't shop head it enough. So then they want you to actually physically check the weight itself to see if it moves. That should be a 100-hour inspection part. When you pull the aileron up, you grab the balance weight and make sure it doesn't move anywhere. If it moves, it's coming off. Okay? Cannot move. Yes, sir.
How often would you check the balance on a control surface? Like, would you do it if you have it off of the aircraft? Or like even if there's like no indication that the balance might be off, would you still go ahead and check it at any point?
You can, but typically when do you check the balance of a control surface? Repaired, repainted, or altered in any way. So, somebody dings a wing, I'm going to check a control surface balance. Okay. So what does that look like for you? Well, here we go. Can you see what I see? All right. So, if we're doing a 172, it's going to tell us the balance weight. So we have an aileron, same as above. Okay. So it means 4.58 pounds, or in this case 3.54 pounds. So you have your beam, and you're going out just like we did with our carbon fiber. We're going to go out a certain amount of inches. Okay? And when we go out a certain amount of inches, we're going to have a window. A window, okay, this one's a little bit harder to do than the others, but you have a window of underbalanced or unbalanced 0 to 2.75 inch-pounds. On the aileron, it's 0 to 10. The one that we're about to do is 0 to 11. Why such a large range, Corbin? Because it's probably a very slow aircraft. Okay? All right? Notice this one here. This is crazy. 0 to 21. 20 inches out. Are you serious? Okay? There's 0 to 41 on the rudder. Pretty crazy. All right, but where would we want, if it was our airplane or we're rigging the airplane, where would we want it to fall? Closer to the higher end so that we alleviate the potential flutter, okay? All right, but if you go to the full 14 manual, which I'll show you tomorrow, I'm trying to kick you out here in just a second. It is super tight window. A very tight window. Why would that be, David? Higher speeds. Yep, higher speeds, greater potential for a flutter. Okay, so we want a tighter range, or Cessna wanted a tighter range. Okay. Here's a control surface balance requirement for, is this 210? Looks like 210. Okay, so aileron 4 to 11. A little bit faster. 172 was 0 to 11. A rudder, -4 to 3. What is that all about? -4. How do you get a negative arm? Yeah, you go past the 0 towards yourself. And so the rudder is allowed to be a -4 to a 3 on the 210. Okay? Right elevator, 0 to 12. Left elevator, 0 to 12. Huge range on the elevator.
So with the rudder, you want to shoot somewhere for 0 then, or?
Good. Nailed it. Yep. You shoot for somewhere around 0. Okay? Because it's perfectly down the middle. Pretty balanced. Okay? You may get a table like this. Oftentimes they'll give you tables like this where it's 2.5 plus or minus 1 ounce that you're allowed, but really the balance weight is 0 to 7 on a 182. Those of you on 182, oh, that's a C. B, 0 to 9. Okay, 0 to 9. Notice this one, 0 to 3 for a rudder. That's all you get. Okay. Any questions?
What are all the numbers again? Where are the measurements coming from?
So that's how they dynamically balanced it at Cessna. When we static balance it, we have to make sure that the balance is within this range.
But what is that range? Is it like measurement from the...
Let's go see. I want everybody out here on this table right here. Walk out the door, let's go to the table.